For over a year, Bering's been announcing that they're developing and bringing to market a laser rangefinder scope utilizing their thermal technology. The final product represents a totally new direction for Bering Optics thermal weapon sights that brings about a new housing, power supply setup, operating system, and application. Over the course of today, I intend to do a thorough overview of the Bering Super Hogster LRF scope. We'll cover things such as an unboxing, battery installation and types, alternate mount systems. We'll also do a range test consisting of shooting 5-shot groups at 100 yards, a digital zoom progression test, and much, much more. Alright, we're going to do an unboxing of the Super Hogster LRF. So, of course, we start here with a very nice soft padded carry case. As we unzip it and look inside, we'll see multiple form-cut compartments and pouches for your supplies and accessories. I'll unzip this top portion, revealing an instruction manual. This instruction manual has many well laid out and clear legible illustrations and directions for your new model scope. Bering will include a set of rechargeable batteries with their scope, which will provide you with many usage cycles of power. You may also get standard alkaline AA's with your scope. Also included is a data power cable for using an external power supply and for transferring files to a personal computer. The standard length cable is going to be 12 inches in length. If you measure it tip to tail, it's actually about 15.5 inches, and it comes with a proprietary shaped omnidirectional connector. A thermal target paster is also included, as well as a shoulder strap for the carry case and a lens cleaning cloth. And of course, the scope is included in the package as well, with an magnesium alloy housing, 2 mount options. This one has a LaRue QD toolless mount. You can also specify a cheaper in-house Bering QD mount. The scope features a robust built-in lens cap for the front lens and a soft rubber lens cover for the LRF unit. Focus is made using the front ring, which provides a fine focus capability. There's a small hole beneath the data power port. That's the onboard audio microphone. The data port is considered a proprietary in shape due to the protective shroud that the scope body has at the connection point to prevent accidental disconnections. Also note the scope mounts are not user serviceable. They're bonded to the scope body with a high strength epoxy. Attempts to remove the scope mount will void the manufacturer's warranty. And rounding out the features is a keyed battery lid with a generous thumb cap that can be used with gloved hands, a rear eyepiece focus adjustment, and a soft eye cup. Tune in to my other video on this channel for a button and menu walkthrough of the LRF thermal sight. Let's cover battery supply and your choices for powering the Super Hogster LRF. Let's begin with one of the most obvious new changes from Bering for their LRF model. The choice of AA power cells is based on many factors, but one key consideration is the wide availability of AA batteries. You'd be hard-pressed to go to any electronics store, hardware store, or gas station and not find some form of AA's, and the best part is they aren't going to cost you very much money. Today I have a wide array of AA batteries to discuss with you. We can begin with the cheapest and most available version, the standard alkaline, non-rechargeable, 1.5 volt battery. You should always use 4 equally charged cells when operating the scope. You can expect to get about 3 hours of use with this choice of battery in moderate temperature weather. Runtime will decrease if you choose to utilize the LRF system continually during your operation. There is another AA battery type that is rechargeable and also runs 1.5 volts. The L-ion, or lithium-ion battery, is rated at 3,000 milliamp hours and will provide you with nearly double the runtime of the standard alkaline batteries at 6 hours. Note that the recharge time of the Li-ion battery is nearly as long as its discharge time, so you might want to purchase a backup set if you plan to use AA's a lot. There's a setting within the menu of the LRF for battery voltage. Assuming that the most common battery types to be used is the standard alkaline or lithium-ion 1.5 volt setups. If you do intend to utilize the following types of batteries, you must change the voltage in the scope on the menu prior to switching the power cells to 1.2 volt battery types. We'll start with the 1.2 volt NiCad or nickel cadmium batteries rated at 2300 milliamp hours. These will provide you with 1.5 hours of runtime. If you're needing more runtime than this, you can utilize the 2800 milliamp hour Ni-MH or nickel metal hydride batteries that will provide you with 5.5 hours of usage. Again, all these runtimes will be impacted if you're using features such as Wi-Fi streaming, the compass, and the LRF mode. You also cannot use a 1.2 volt battery charger on 1.5 volt batteries, or vice versa. You may not use 1.5 volt battery chargers on 1.2 volt batteries. It may be wise to write down on the battery charger what type of battery and voltage it is with a black permanent marker so you can keep your battery cells in tip-top shape. I had mentioned previously that you could specify the Super Hogster LRF with an in-house Bering Optics QD mount. Let's look at the alternate scope mount at this time. If you elect to save a couple of $100 and specify that you'd like the Bering Optics QD mount, you'll find that you've not given away anything in terms of robustness or quality. Bering has been in the scope market for many years, and their engineers are keen towards what a good, dependable, and solid mount is constructed with and what it offers users in terms of performance. The in-house Bering mount comes with a D-loop metal installed into the scope mount that can be attached to a lanyard, and if you'd like to use the optic for double duty as a monocular spotter and a weapon sight, you'll find the D-loop is of a high-grade metal and will easily withstand the heavy use and can support the scope's weight without any concerns. So just wanted to let you know of the alternate scope mount option for your Super Hogster LRF. All right, folks, before we get to zeroing the Super Hogster LRF model, I'm going to proof my ammunition and my firearm with a high-power daytime optic. I do this so that I understand what my ammunition and my gun give me in the most optimal precision aiming situation. Let's say I shoot 1.25 inches spread in a 5-shot group. Then I would not expect to put the Super Hogster on the same gun with the same ammunition and best that. Ordinarily, the aiming points and the ability to aim on target is much more precise in daytime. This is almost barely an inch in diameter, and with that high magnification scope, I can really dial in and settle in steadily on the very center of it. So I can aim smaller with that daytime optic in my rifle setup than I can with thermal. Thermal, there's going to be a little bit of bloom with the thermal targets that we're using, and I find that normally you increase by 3/4 of an inch to an inch when you shoot the same rifle and ammunition with thermal. And so that's why we're going to run through this. If this section of the video doesn't pertain to you and you know already what your firearm and your ammunition produce and you've been using that gun for a long time, skip ahead. Go ahead and skip ahead to the Super Hogster zeroing. But I find there's a small subset of customers and hunters, fellow hunters, they get excited about getting a brand new thermal optic and they go ahead and get themselves a new upper or a new caliber. And they put that new caliber together and they put the new scope on, and sometimes when accuracy isn't what's expected, you know, we have to troubleshoot that all the way back to the beginning, which is use a daytime optic with the rifle and ammunition. So that's the point of what we're about to get into. Okay, I've gone ahead and zeroed at 100 yards. I'm going to shoot a 5-shot group now with the daytime optic before we get to zeroing the Super Hogster LRF. I will try to run a target camera as well, so you can see the impacts real time. 5 shots. All right, we'll go down and take a look. All right, so there's our results. 5 shots, 100 yards, 6.5 Grendel, 90 grain factory ammunition with a daytime optic. You can essentially cover those with a thumb. So, now we have the baseline accuracy established. We'll go ahead and get the Super Hogster LRF on the gun. The spotlight on the Super Hogster LRF. This one's outfitted with a LaRue toolless mount. So factory fresh, never been mounted before. What I like to do is, since there may be little burrs or little globs of grease in there or whatnot, I just season my mount. So I turn the adjustment screw right and left 3 full revolutions just to work things in. So now I'm at the bottom of the adjustment range. I like to go into the 6th slot on my AR-15s, and it's way too loose. So I will adjust the adjustment nut 4 clicks. 1, 2, 3, 4. Still too loose. You want to get firm pressure about 30 degrees out. 1, 2, 3, 4. Tightening up at about 20 degrees out. So let's go 3 clicks. 3. Nope, still too loose. 1, 2, 3. That was better. Let me go 2 more clicks. I'm able to do this, well, very moderate finger pressure. You shouldn't have to bang it on and bang it off. 1 more click. So at about 30 degrees out, it gives me firm pressure, and then I have to override that and then lock it down. So the scope is mounted. Take my lens covers off. Do not forget to take the lens cover off your LRF if you plan to use it. Ask me how I know. Got batteries on board. We'll get powered up. Now, real quick, same target style base media that we're going to use. We use one of these thermal pasters that was included with the optic. Has an adhesive backer. Put that relatively in the center. Has some chemical thermal compound in there that with the oxygen reaction it'll start to heat up for us. But here's the difference in the 2 aiming points between the daytime optic and the thermal. So daytime optic being just about 1 inch wide, and this one being nearly twice the size, 2 inches wide. So as I discussed, I got about a 3/4 of an inch to 1 inch grouping with the daytime optic here. I have typically found that I doubled that with thermal optics. It's not because necessarily of the thermal optic itself, it's just the refinement of the reticle and the aiming point. It's a lot less refined for thermal than it is for a high precision. I was using 25 power to shoot this group. So set reasonable expectations. Now I grant you, if you get the Super Hogster on the gun, you know what it does, and it's shooting 3 to 4 MOA we got an issue. There's either a scope base on the gun that's loose. We will troubleshoot that in order to find what the issue is. You should not go from a 1-inch gun to a 3 to 4-inch gun just by putting thermal on it. But I will accept 2 MOA, double of what I produced with a high magnification optic. I will be ecstatic if I can match this or best it. I mean, that's not my expectation. That's a bonus if it happens. So I'll go down, I'll post the thermal target. We'll shoot a couple shots on a steel target at 50 to get close, and then I'll go ahead and clue you in with the video from the scope for the 100-yard zero. Okay, we have the Super Hogster LRF mounted on a 6.5 Grendel. We're looking at a steel silhouette target at 50 yards. On screen I have my reticle, white crosshair inlaid in black larger crosshair, and then above it, about the noon position, is the LRF guide box, which is a blue X cross marking. It's currently reading 52 yards to target, which is accurate. I will take one shot and then adjust the 0 at 50 relatively close and then move to 100. Alright, I am low on impact, not by much, so not much adjustment will be necessary. Stand by. Alright, so I got a rough 0 at 50. I'm ready to go to 100 yards. These will be the sighters at 100 yards, so I will shoot 2. And then we'll go down and mark those sighters with another pasty thermal target. I'll show you that process. So powering up the scope. Seems to be about a 14 to 15 second startup before all the reticles and menus become live and active. To record, you press and hold the rear 2 buttons together simultaneously for 3 seconds. So I'll go ahead and bring you in. There we are. Okay, so our provided thermal paster is downrange. Now, through the scope in the main window, the inlaid reticle is white, but in picture-in-picture it is black. So on the video it'll probably seem like I'm using a black reticle to aim on a black target, but I'm using picture-in-picture, which is white. Okay, here we go. 2 shots. Base magnification, I don't generally like to introduce any digital zoom value into my zeroing process. Today's 95 degrees, so everything is thermally soaked at this point, but I still am able to get a very good image with the Super Hogster LRF at 100 yards where I feel comfortable using base magnification, which is 3.5 times. It registers as 3.5 in the upper left. To zoom, you use this front and rear button, and it goes from 3.5 on up to 14 times. So we'll leave it at 3.5, which is base. Two shots. To terminate the recording, you press those 2 buttons again simultaneously. Recording is terminated. To go into standby, you press the power button for about 2 seconds, let go, and go to standby. Alright, so down here at the target camera, we can see that those 2 impacts are about a thumb width apart. So that speaks to the accuracy of the ammunition and rifle being in check. Good to go with the Super Hogster LRF. If you didn't start at 50, let's say, and these were way over here, I would introduce another thermal paster and put it over where the impacts are, so that when you adjust at the bench, it's easier to get a defined lock on the 0. For this, all I got to do is
go adjust to where I'm nearly off the hot spot, and that should be perfect. So let me go do that now. All right, we're going to make a final adjustment for 100 yard zero. I'll wake the scope up by pressing any button. I will explain what I'm doing since you won't be able to see the menu in the recorded video. So I will press and long hold the menu button. I will go down to the bottom to get to page 2. The second item is your zeroing. It has a 100 yard setting there. Click on that. Next, it offers you 3 different zeroing profiles for that rifle profile, 100, 200, 300. I'm doing 100, so I'll select that. Gives you 2 options, a reticle to adjust X and Y, or option to change the name from 100 to something else. So I'll click on the reticle. And I will adjust X first, which is right to left, and since I was in the center, windage wise, no adjustment necessary to X. So I will go straight to Y, press the menu button to select. I know it's ready for an input because the Y value is going to blink. And I want to go down in order to come up on target. So I made a 3 value correction there. So my X is minus 2.31 inches. And my Y is minus 6.48 inches. Just as a basis of comparison once you get started zeroing your Super Hogster LRF. So not a very wide, or not a very large adjustment necessary to get zeroed at 100, which is fantastic. That means Bering at the factory collimated on their machines the mount to scope body alignment so that you wouldn't have to adjust too much here at the bench. So plus marks to Bering for that. In order to save, no values blinking, so you press and hold that middle menu button, save and exit with a question mark comes up. I'm going to go down to yes and click the middle menu button. There's a little bit of a lag, maybe 3-second lag before that disappears. Then to go back to the main menu, you press and hold again. It asks you to save and exit again. Yes, and one more time, press and hold, yes, and now we're back to the main menu, and I think you have to go back to page 1 in order to press and hold to get back to the non-menu screen. So, zero's been adjusted. We have a target camera running down range. Let me load 5 rounds. Let me bring you into the recording. Go to standby. Down and check. Okay, so 5 shots all impacted on the thermal hand warmer. I was able to cover the daytime optic group with the thumb. So as you see, I have an outlier there, which was to be expected. So this distance here is almost double, almost 2 MOA. So as I explained, that's what I expected to see. I do have 3 almost within an inch, which is a nice bonus to have. All right, it's back at the bench. At this point, we would be good to go to the field with this. The gun, the ammunition, and the optic are operating so well, I'd feel good about headshot on a hog at 100 yards if I wanted to do that. We will look for in future testing and evaluation. This is the first day out with this optic, but I plan to hunt it within the next month. So we'll look over the course of the next month that it maintains this ability to group within 2 inches or less with this gun and ammunition. What I plan to do now is, since this is a full comprehensive review, is those of you who are interested in sticking around, I'm going to do a digital zoom progression test. So what that looks like is I place additional hot hands at 3 points on the target. I'll cut this one in half. This is your standard hot hand size, so it's about the size of a palm. I'll cut it in half so that it's a smaller target to aim at. I'll post it at 2 times and 3 times, and then I use the extra thermal paster at 4 times. So the point here is, if I initiated digital zoom, now that I have a base 0xy input into the scope, if I want to go to 2 times, which is going to be 7.0 times in the main HUD readout, does the point of impact correlate with the digital zoom? There have been instances in the past with other thermal optics where that digital zoom does not correlate, and so it essentially is useless if you can't stay on the same point of impact. So this is a test I like to do to ensure that 2 times, 3 times, which is 10.5x, or 4 times, which is 14x, that we are landing within 2 inches of this cut thermal target. It can vary, I would say, anywhere from 1.5 inches, left, right, up, or down would be acceptable, because again, it's like a 2 MOA accuracy with the optic and the rifle and ammunition. So what I don't want to see is, if I have this here at 2 times on digital zoom, that it impacts 5 inches high or 5 inches low or 5 inches right. So we're looking for gross error in this test. All right, let me cut these hot hands and go close to target, and we'll do the digital zoom test. So you'll see 5 hot spots. We're not going to use the middle. We're going to start on the low right, which is set up for base magnification. 1 shot on that. No powder. Okay. We are going to increase digital magnification to 7 times. There we go. To calibrate, you press the power key 1 time quickly. Calibrated, make sure we're focused. We're focused. Going to 3 times, which is 10.5. Upper right. And finishing out at 4 times magnification, digital magnification, 14 times. Lower left. Back to base mag. Recording off. Okay, base magnification was just at the top of the hand warmer. We did make contact with it, but I had it taped so well that the powder didn't fall out. 2 times. Are we within the reasonable allotment of 2 MOA? Yes. So there's your impact there. 3 times? Yes. Good. And 4 times? Yes. So everything checks out. My eyes and my shooting position and configuration, seems like when I put digital zoom on, I get a little bit to the left, all impacted left of the hand warmer. But since it's consistent, I can just factor that. All right, so that's the range test for the Super Hogster LRF. Let's get back to the bench with final thoughts. All right, well, thanks for watching today. I hope this was informative. The scope performed flawlessly. No glitches, no hang-ups, handles recoil just fine, and is rated for high recoil. The batteries, I had the nickel cadmium batteries in here. They lasted throughout the entire range trip. Focus was good and precise and sharp. I do want to say on the laser rangefinder, okay, they collimate that, or they give you a guide box, the blue crosshatch, and for a 1200 yard laser, it wouldn't be possible to have it track the entire 1200 yards precisely and accurately, dead nuts on point. So they set it up at the factory, and the guide box, the crosshatch, just gives you a general guide of where to place your laser for the ping back for accuracy of yardage. Now, folks, this isn't a scientific instrument. We're not sending readings to NASA. So build into it, I would say if you're ranging at 300, 600 yards, you know, build in a 5 to 10 yard buffer there. It could be plus or minus 5 to 10 yards. Now, a lot of that has to do with environmental conditions, the deflection of target. You know, is it square or is it slightly quartering away? The density of the target that it's reading off of, there's a number of factors. So I just hate to see folks get hung up on not being able to adjust the blue crosshatch to their liking. The factory's done it for us, and we just have to use it as an additional tool in the field, but don't become reliant that it's 100% to the yard all the way through the 1200 yard range. So that's my disclaimer. Whether I'm right or wrong, we can all have our opinions on that. But that's been my experience, not just with today's use of this LRF, but all the other LRF scopes I've ever used from other manufacturers. All right, well, good day to you, and we'll have more videos coming up. I plan to cover the new application that has been developed for this scope. I plan to do a side-by-side comparison with a competitor's LRF that I own. So I'll be bringing you side-by-side videos there. And then I'll give you the month update on how we did. So thanks for watching.